Okay, so a question that was asked of me this weekend is, of the material for the lecture test that I outlined or put in a list and sent you. If you haven't seen that list, you need to look at your email. But well, the question was, for instance, with bones, there are four basic shapes of bones: long bones, short bones, irregular bones, and flat bones. Are we going to have to know what each bone is? In other words, if I name a bone, do you have to know if it's long, short, irregular, or flat? If I name a bone, you should definitely know the answer to that. I will not pick some obscure bone that would give you trouble. Okay. Uh, so, for instance, uh, the femur, is that long, short, irregular, or flat?
Long.
It's a long bone. Thanks, Kevin. The phalanges in the fingers, are they long, short?
Short.
Yeah. How about the ethmoid bone, the sphenoid bone? Those two, long, short, irregular, or flat?
Irregular.
They're irregular. I think somebody else said it, but it was so uh, uh, quietly. Uh, I want to give credit to it. Yes, irregular. And then a flat bone. You name it for me.
Parietal.
What did you say?
The parietal bone on the head.
Parietal. Parietal. Yes, absolutely. Even though it's not perfectly flat, we don't have flat as pancake bones, but closest thing to really being flat would be the sternum. Okay, now I will not pick a bone that would be problematic. Okay, for instance, here's a problematic bone. Which category would you put it in? The hyoid bone. Long, short, irregular, or flat? I don't know the answer to that. I could look it up, but that just uh, doesn't seem like a fair question, does it? Okay. Even though it's curved, it's probably a long bone. Okay. I've never worried about it, but since I did mention that their bones are going to be on, bone material is going to be on the lecture exam. You just took the bone practicum. You are well studied for any questions, so long as you don't forget them between now and next week, and you won't. You're well situated for questions on the bones that I'll be asking. Probably the clearest thinking you have to do is when you're asked how many of this kind of bone or that kind of bone there are in the human body. That means the entire human body, the right side, the left side, or in a bone box that has everything, okay, or a skeleton that's hanging in the classroom if we were there. So, uh, toughest one is, for instance, how many carpals do we have? And the first thing you got to do is try to remember what is a carpal, okay, and then how many carpals do we have, and do we have them on one side of the body or both? So think about it for a second and tell me how many carpals we have.
Would it be 20?
No, but thank you.
16.
16. Carpals are the wrist bones. Okay. The 20 would have been well, that wouldn't answer anything. If you were thinking of the metacarpals, there's 5 in each hand, we'd have 10. And then if we're talking about the metatarsals, which are associated with the foot, we would have 10 there as well. Okay, one more chance here. How about tarsals? How many do we have in the human body? Not 5.
Can you repeat the question?
How many tarsals in a complete human body?
Would it be 10?
No, but thank you.
Okay.
14.
14. 7 tarsals in each foot. That the tarsals are the calcaneus, the cuboid, the 3 cuneiforms, the navicular, and the talus. Okay. If you had any trouble with that at all, or had to think longer than you really think you want to on the exam, you might want to review the number of bones and of different types. You won't find that it's very hard. Okay. If a common one for me to ask is, how many ribs are there? Well, somebody might say 12, but they've got 12 on the other side too. So you got 24 ribs. Okay. I could also say, how many true ribs do you have? Well, there are 7 pairs of true ribs. Pairs, that means times 2. 7 times 2, 14. If you take another look at that list that I sent you of what's going to be on the lecture exam, you can always email me individual questions, but I actually appreciate it so long as we have the time that we do it here, you know. So on Thursday, if you've got any questions that are saved up, you can ask them for the benefit of everybody. Okay. Chris, I muted you. Hope you don't mind. Everybody knows how to unmute. Just hit the space bar or hit the microphone. Okay. When we get to the module, it'll say the first thing, you know, the assignment and such. I want to go over the assignment with you for this week. This is a long one, and we only have a week and 2 days until the practical. I'm getting these mixed up. Only have a week and 2 days until we get to the lecture exam. So I would encourage you to jump on this and get it finished. Okay, so it's chapter 23, the digestive system. The recommended due date, I'm going to change the way I say that. The recommended due date is next Monday night, okay, at midnight. I have taken many of these late, but in turning them in late, at least you have done the reading, you have done the work, and this is not a critical time sensitive assignment as far as I'm concerned. But I have a recommended due date for you. And if you turn it in late, what you're going to end up doing, unfortunately, is pushing everything up right against the next test. So best to get it out of the way. My book at chapter 23 starts on page 676. Yours is going to be a different page, I'm sure. In Miriam. It starts with a paragraph of nothing. It has an overview of nothing that is going to be surprising. So that doesn't need to be outlined. This is just telling you what's going to come. It has a diagram of the parts of the digestive system. Mine has a male turned anatomically towards us, but head turned, and has all the digestive organs. I would look at that, but I would not outline it. I would take note of anything I don't know, and then I will pay extra attention to that when I get to it. I have figure 23 dash or dot 2, 23.2. And this is the body divided into ninths. Okay. Sometimes the body is divided into quadrants or fourths. Please ignore this. So far I haven't given you anything to write down. If you're going to become a surgeon, you're going to have this memorized so well. Great. But until you get to that stage, you don't need to know the division of the body into ninths. After overview, you should find the word bolded, alimentary canal. I don't know if you were talking to me or not, but you're awfully low on volume. I'll turn mine up. Okay, alimentary canal, accessory digestive organs. Yes, those two terms. But abdominal regions, no. That refers to that chart that I just told you to not worry about, the division into ninths. So that continues on till clinical application. These clinical applications are usually quite interesting, but they're not part of the outlining that you have to do. You'll probably read them anyway, just out of curiosity. The first one is bowel sounds, for instance. We used to call it tummy rumbling. Did your tummy used to rumble in grade school before lunch? Next page. Figure 23.3. Skip it. It's 2 pages long. Please skip it. Go to the peroneal or peritoneal cavity and the peritoneum. That we need to begin reading. This is more serious. Okay. Visceral peritoneum, parietal peritoneum, and the peritoneal cavity, yes. Skip the clinical application. Mesenteries, that entire section needs to be read. Okay. There'll be plenty of questions about that. The diagram, figure 23.4, is for your reference in the reading. You don't need to include the diagram itself in the outline. That will be very helpful, however, to you. Okay, so we did mesenteries, and I'm going to flip the page. You may not be flipping the page. Digestive processes, yes. Okay, they have 6 of them here, starting with ingestion. Please read that portion. Okay. I have a check your understanding, and we'll skip that. Okay. I'm not saying don't read it. I'm saying don't outline it. Okay. Anatomy of the alimentary canal. That is a yes. The histology will be included in our lecture. So yes, histology. Mucosa, submucosa, yes. Muscularis externa, serosa. The diagram on figure 23-7, there's 2 of them there. Very important diagrams. Nothing that you can outline. You'd have to just redraw the whole thing. That's not necessary these days. But please look over those diagrams after you finish the reading so that you can see what was being talked about. I'm at smooth muscle, and that is a yes. Pick up the reading on smooth muscle. Mechanism of contraction, yes. Innervation of smooth muscle and glands. Innervation makes something work. But then when you come to enteric nervous system, if you don't see it, tell me. But the enteric nervous system, no. And the following material to check your understanding, no. That's on nervous system. We'll hit nervous system independently. Okay, here we go with the mouth, yes. Histology of the mouth, yes. Lips and cheeks, yes. Tongue, yes. That includes the tongue itself and the frenula, lingual frenulum. Teeth, no. I'm at a clinical application followed by a figure of the dentation, so no to those. Next page. Figure of the tooth, no. The text for the tooth, no. The dentition markings, that's the looks like code up there, a math symbol, no. Vessels and nerves, no. No, nothing to do with the teeth at this point. I get then to clinical application, and no. Pick up the reading at salivary gland. The first 2 paragraphs, yes. To clinical application, skip that. Pick it up again at submandibular gland and sublingual gland. Microscopic anatomy, no. We are going to do microscopic anatomy of the salivary gland, but we do that in the last practicum section. So no for our outlining. The pharynx, yes. It's a very short area here. Until you get to check your understanding, skip that. The esophagus, yes. Microscopic anatomy, no. Here on out, anything that says microscopic anatomy in this chapter, no, you won't be doing it here. You will be doing it later on. The clinical application, no. The stomach, absolutely, of course. And Continue the stomach reading until you get to microscopic anatomy. Skip it. Skip it for now. We're not skipping it forever. There's a lot of microscopic anatomy, so take away quite a few paragraphs. The small intestine, yes, until you get to microscopic anatomy. The okay, then the small intestine, definitely we pick up that because that's the major organ of digestion. Read the portion of it until you get to small microscopic anatomy. It actually makes it look like you're reading just a smaller half of this section. That's true, but we are going to get to the microscopic anatomy. Okay. You can skip any other part of that small intestine dealing with microscopic anatomy, and then you'll come to the large intestine. The large intestine, the same thing. We start with gross anatomy, skip the clinical application, then the colon, the rectum, anal canal are all included. Skip the clinical application. Vessels and nerves, no to vessels and nerves. Coming to the end here. Okay, and skip the clinical application, read the paragraph, and then you come to microscopic anatomy. It's a wonderful thing to actually look at under the microscope or on the screen, but we won't do microscopic anatomy at this point. Okay, so what I'm having you do is get an overview of the organs, overview of what each organ is doing. Okay, I'm going to have you stop there. Once you hit microscopic anatomy, stop. 2 pages further on, you'll see the liver, another very, very important organ. But those are accessory organs, and I'll cover those separately. Okay. I'll cover them. You'll be responsible for them, but you do not have to outline the accessory organs. Some of you may want to. Some of you may benefit from the outlining. Do I have you outline just because I want something to do for you? Do I have to have homework? Hell, I always hated homework. But there was a time when I did not do outlines. And some other instructors did, and I thought, oh my God, sending them home to do that, rewrite it, although our outlines are shorter. But I decided to try it once. And as soon as I tried it, the lecture exam scores, which are always lower, as I said before, than the practical exam scores. The lecture exam scores went up 10% across the board in the class. Obviously, I have kept it ever since. Okay? Sometimes we call things like that a necessary evil. Okay, and it really works. I used to assign readings on a sort of voluntary basis, but now I do collect it, and I think it has really helped. And okay, that's my take on it. Any questions? Okay, going to split the screen then. Okay, you're seeing the screen, please?
Yeah, I see it.
Okay. Okay. Module 4 was last week, and that included the bone practicum, which we ended up at. And I took two things out. When these are light like this, you can't see them on your screen. Uh, One I took out was x-rays. You did fine on the x-ray questions anyway. And a lecture had intended to give last week, but we spent time reviewing instead, is postponed until today. So now we'll go down a little bit farther. And here's practice quiz for the fourth week module. And way back, I would think on the third week, somebody asked me, instead of posting the practice quiz on Friday, which is what I used to do, could they have it earlier? Could they have it earlier? And I said, I don't think it's going to help much, but yes, you can have it earlier. All I have to do is, turn one of these buttons red, and there it is, because I'll probably use the same practice quizzes. I don't use the same test. Well, I did that, and not a single person took the practice quiz early. It didn't happen. So I'll still post them early, but I don't see that doing that had much effect. Now, the practice quiz for last week's module, had you gone there, was based upon this postponed lecture. So if you looked at this practice quiz, you would be getting a lot of muscle type questions that you couldn't answer, and you gave up on it. I don't blame you. 10 people took the quiz anyway, but I don't know if they spent time looking things up, but that's what happened there. Those questions are going to be asked. I'm going to pull that. I'm going to pull it down here. Okay, here's the practice quiz for this week, number 5. This is in preparation for the lecture exam. It has questions from the start. Okay, so it has not just muscle questions, it has bone questions and joint questions and cell structure questions. The module 4 quiz, I just pulled it down, and it'll be there available to you as well this week. The discussion for this week. Okay, we've got a lot of people who have already begun it, and a lot more that need to. Okay. I'm sort of reading. Sorry. Okay, it's basically your opinion of how you did on practicum 1 and how it was presented. So that's not hard. The assignment for this week, no need of me opening that up. It's chapter 23, the digestive system. Okay. Okay, next we go to the moved lecture. It's on myofibrils and the sliding filament theory. Well, that sounds like a mouthful. The previous lecture, given about 10, 12 days ago, something like that, leading into this, was on muscle tissue, on smooth muscle, skeletal muscle, cardiac muscle. Okay. We talked about the belly of the muscle, the origin, the insertion. And that's, of course, still all there in the notes and in the uh, recording. This picture should look familiar. This was the last picture that you saw from the last lecture. Okay, I reproduced it here so that we'd have a sort of a review and a starting point. This is the belly of the muscle. The tendon is off screen. That attaches the muscle to bone. Here's the belly, and it has inside of it these compartmentalized areas called fasciculi. If I could draw or pull a fasciculus out, here it would be. This is a fasciculus. The entire belly of the muscle is surrounded by a connective tissue called epimysium. Here's the term right over here. The fasciculus is surrounded by this tissue, which is connected to the outer tissue, but it gets another name. This is called paramecium. Here's the term down here, paramecium. Inside of the fasciculus are a number of strands. Each is called a muscle fiber. A muscle fiber is also known as a muscle cell. They're interchangeable. If you could see, and maybe I'll make it a little bit longer. Between the muscle cells, here, here, there's another connective tissue. This is the endomysium. If we could take a single muscle cell, any one of these inside of the fasciculus, and pull it out like we're doing here, this would be a single muscle cell or a single muscle fiber being pulled out. They're sort of stripping it in the picture, but this whole thing is a muscle cell. People think often, well, if it's a muscle cell, that's got to be the smallest unit. No, 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 no. Inside we have organelles, and these are called myofibrils. When we see a striated muscle, a voluntary muscle, we call it striated because it has the streaks, parallel streaks, running perpendicular to the way the muscle runs. We saw that before, and I'm going to have to trust here that you'll either go back to review it or you still remember it. Okay. And those streaks actually originate in the myofibril. You can barely see some streaking here. Well, if I took all the myofibrils, only one is present here, but if I had all of them and I pushed them back in, the streaks would line up and intensify in darkness under the microscope. And this would all be streaked. And then if I took the muscle cell of only of which only one is shown here, and pushed all of them back into the fasciculus, all the streaks would line up. And if I pushed all the fasciculi back into the muscle belly itself, it would be striated on the outside. All the streaking or all the striations would line up and really give us a nice picture of a striated muscle. Okay. You have lots of diagrams in the textbook. So many diagrams that you can get confused. Okay. So if you stick to our description here, or any one description that you prefer, I think you'll be better off than mixing a whole bunch of these. Okay. Our description here is totally adequate for you to do perfectly on our exams. Now, remember, this is going to be on the test a week from Thursday. So as you go over this material and you have any problem with it or need to review it, just bring it up on this Thursday or next Tuesday or by email. This is a myofibril. Where did that come from? It's here. I've just sectioned off a piece of myofibril. If I stack all the myofibrils together, back, I'm going to get all the striations that you'll see lined up. Okay. This has got to look immediately, if you've never seen it before, it's got to look complicated. It's really not. It's really not. The myofibril is broken into compartments. Okay. Here's where the break occurs at the zigzag line here. This is called the Z line. Think of zigzag. The book won't tell you to do this. And a Z line. Here's another Z line. And there are hundreds of these going down the length of the myofibril. That's how long it is. From one Z line to the next is a sarcomere. A sarcomere is simply a compartment. The Z line is a wall that doesn't just go around the outside of the myofibril. It's like a disc, a Necco wafer. Okay, if you can remember those. Okay, a dime. It's a disc, flat and round, that goes right on through. It's a plate. It's a plate. It separates this side of the Z line from this side, from this side. This is part of a sarcomere. This is a full sarcomere. This is part of a sarcomere. Inside of the sarcomere, we have thick filaments. That's these guys here. I think I prefer to put them over here. Thick filaments. They're composed of a protein called myosin, which I'll get back to in just a moment. You don't have to worry about that right now. This is a thicker filament. These attach at the center, and that's the M line. The center of the sarcomere has the M line. No book will tell you this, but M just simply stands for middle. The thick filaments attach to the M line. The thin filaments attach to the Z line. This way, this way. Now, if you're thinking two-dimensionally, you're shortchanging yourself. You got to think three-dimensionally. You've got all of these thin filaments sticking inward from both sides, from both Z lines, but not just at the edge, in the middle of that Z disc, or disc that I refer to as a dime or a plate, going all the way across, or a wafer. They're coming up all over like bristles on a brush. And the thick filaments are sticking in between. They are not touching. The thick filaments are not touching the thin filaments when the muscle is relaxed. That won't be the case when the muscle contracts. But for right now in this picture, the thin filament does not touch the thick filament. The thick filament does not touch the Z line. Okay. In the relaxed muscle. And in the relaxed muscle, the thin filament does not touch the M line. It's just as it's drawn. Now that will change. That will change when we contract the muscle. Okay, the part of the biofilament occupied by thick filaments is the myofibril. Occupied by thick filaments is called the A band. From here to here is the A band. From here over to here, the lighter area, is the I band. It straddles or crosses the Z line. The A band has at its center the M line, to which all the thick filaments attach. Okay, take a look down here, A band. A goes from the end of the thick filament to the end of the thick filament pair. There's two thick filaments joining at the M line. Where's the M line? Not in this picture. The M line is that middle one, not labeled. Okay. We'll get to the H zone in just a second. I band, A band, I band, A band. A band has what kind of filaments? Thick, thin, or both? If I were to section a piece of this off, would I get both or just only one of thick or thin filaments?
Both.
What'd you say?
Both.
Both, yes. There's only three answers here. So, and that was the correct one. Thank you. You would get both. You would actually get both. If so, the A band consists of thick and thin filaments all the time. What is the width or length, actually, of the A band from here to here? The width of the A band, or the length of the A band, it doesn't matter which way you say it this time, goes from here to here. The thick filaments don't change their size. Even during contraction, they don't change their size. So the A band will always be that wide, always be this wide. The area over here for the I band, when contraction occurs, we are going to force this side into this side into this side. We can't scrunch the A bands. We can't scrunch the thick filaments in the A bands, but we can move into this area here. And the I band will get smaller. Will get smaller as the muscle contracts. Now here, instead of calling it a Z line, they have changed to calling it a Z disc, which I prefer actually, because that's that wafer that we talked about. The area from the end of one thin filament, a thin filament attached to the Z disc, heads in towards the middle. The midline is here, but not labeled. And there's a space in between. This is called the H zone. The H zone has only thick filaments. Now I've written that up here for you. The H zone represents the area of the myofibril that has thick filaments but no thin filaments. So the thick filaments are only here. Both are out here, and only the thin filaments are out here. That does allow them to contract. You could take this end, one hand, this end, one hand, squeeze together and bring these closer to each other. The thin filaments can move into the space that's still there, in the H zone. They cannot, however, bump into their counterpart on the other side because of the M line. That's as far as they could possibly go. When we talk about muscle contraction, we use the term origin and insertion. Okay. Origin doesn't move. Insertion moves towards the origin. Imagine you have an accordion. When I was a kid, salesmen used to come around to our house all the time trying to get parents to sign up their kids to play the accordion. Thank God my parents didn't have enough money for that. Oh, God. Okay. The keyboard on an accordion for a right-handed person, okay, is going to be at your chest. Put the keyboard of the accordion at your imaginary chest, okay? And then your other hand is in a strap way out at the end of the bellows on the left-hand side. And when I say bellows, you know what I'm talking about, how it's pleated. They're pleated. When you contract an accordion, it's like contracting a muscle. The origin, the keyboard, stays still. And the end of the bellows moves towards the origin. Okay, that's the insertion. Now, for us, if we had an accordion, we would then bring the bellows back out with another muscular motion or movement. In the skeletal system, the muscles there, one of them contracts and another muscle, a counterpart, returns the muscle to its original state. Okay. Here's the M line after all, is here. It certainly looks the same as an H zone. M line refers to the midline only, though, the middle line. The H zone is from here to here. I'll get to that one just a second. What would happen when a muscle contracts? Well, what happens to these A bands and I bands? When we look at a muscle under the microscope, a striated muscle, we see band, clear area, band, clear area, band, clear area. Well, here's what's making the band, the dense A band. Then we have a clear I band and another A band for density, I band, and A band. Okay. That gives us our striation. Okay, we have thousands upon thousands of these myofibrils lined up. We're going to see quite a bit of striation. Now, when the muscle contracts, it's going to contract in one direction. It's going to contract for the insertion to go to the origin. Let's make this the insertion. Okay, and here's the origin. It's going to stay put. But the muscle is going to contract when calcium is released into the muscle itself. Okay, so when that happens, this end of the muscle moves this way, the whole thing. You're pushing it. You've got your hand on both ends, but you're not pushing with the other end at the origin. You're pushing at the insertion. And you're pushing these threads or filaments in between other filaments. Actually, the thin and thick filament during contraction, then only they will touch each other. And they actually can crawl, if I can use the word, crawl, chemically crawl. Uh, uh, and they would, doesn't matter which way they try to crawl, right or left, they can only go one way. They can only go this way because the origin stays still. Okay, the origin stays still. Picture this as a person here, the A band, with arms stretched out, cords to this wall, to this wall. Now, tighten your chest muscles and pull this wall in. Pull that wall in. They don't break or anything. You can't pull this wall because this is not moving. You can pull this wall, however, because this end is moving. And you pull it and you'll step to the side and you'll get closer and closer to this wall. Everything will come this way in our imaginary muscle with an insertion over here. The A band will stay the same size. The A band does not get smaller during contraction. The I band, however, can get obliterated as the filaments move into it. The H zone can also disappear completely at that time. Why? Because the thin filaments are moving in and just almost touching. Something's got to get smaller. In contraction, nothing gets larger. So when you're looking at I band, A band, and H zone, A band stays the same. I band gets smaller and the H zone gets smaller as well. This is a different view, I sort of like it, of a myofibril set up, okay? This is a thick filament, we'll start there. And here's the M line that the two thick filaments in a pair adhere to. There's other thick filaments. They have bristles at their ends, this side and this side. The thin filament is here, and here's the Z line, zigzag line. More thin filaments, more thin filaments, more, sticking in between the thick filaments. But they're not touching. They're not touching when the muscle is relaxed. Nothing, they can spin. They can spin on their axis, long axis, but it doesn't do them any good, okay? That's a thick filament. Thin filaments can't spin on their axis at all. Okay? The A band goes from the end of the thick filament to the end of the thick filament. The I band goes from thin filament to thin filament and straddles the Z line. The H zone is the only one that has only thick filaments. The A band has both thick and thin, thick and thin, thick and thin. Okay, a brief summary of some of the terms. Sarcomere, that's the area between two Z lines. The Z line, the partition, thin myofilaments attached here. A band we looked at. The A band is composed of thick and thin filaments. It does not shrink during muscle contraction. I band, the lighter areas alternating with the A bands. When the muscle contracts, the lighter areas are going away temporarily, and the muscle under the microscope will look darker. You very seldom see a muscle that looks very dark under the microscope put onto a textbook page, because in order to get that contraction frozen in time, you've got to kill the specimen while its muscle is contracting. Okay? You may not be able to kill it, but you can quick freeze it, and occasionally you get to see one. The I band, during contraction, the I band shrinks in size. H zone shrinks during muscle contraction. This is nothing new. Thick filament, thin filament, nothing new. Okay, here's a thin filament. We're going to look at one of those, and we have actually looked at a thick filament. Thick filament has these heads on both ends. Okay. It would like to attach to the thin filament. If it could attach to the thin filament, the spinning of the thick filament could cause sort of a ratcheting effect and move it towards the Z line in both directions at the same time. If you, most people don't know what a turnbuckle is, and it's a hard idea to wrap your head around unless you already do know what it is. But you turn the centerpiece and it moves in both directions, this way and this way. Okay? Now, the thick filament during contraction does not get smaller. So it also doesn't go to the right or to the left. It turns against these thin filaments and draws them both in, makes these compartment, the sarcomere, smaller. Okay? Those sarcomeres will move towards the origin, but each sarcomere is getting smaller during contraction. It's like turning a screw, and it wants to move this way. Turning a screw and it wants to move this way. Well, it can't move because it would have to split. So instead, it moves what it's going through, and that's the tunnel of thin filaments. It moves these in. The thin filament consists of 3 proteins. Don't worry, we're almost done. 3 proteins. First, it has 2 spiraling layers of beads or protein called actin. It's actually called F-actin, fibrous actin. And if you have a strand of beads, a strand of pearls. When I was a kid, my sister had pop beads and they would stick together. I don't know if you can think of those, but you can think of a strand of pearls. A single strand of pearls, like this, and then it comes out behind here. Double up and have two strands of pearls side by side and twist them. This is two strands. These are two strands side by side. If you don't twist these pearls, if you have two strands, how many grooves do you have between the two strands of pearls? Now that's probably difficult to see, but the answer is two. Okay. Put two pencils on an imaginary piece of paper. Put two fingers together. You all have that in front of you. Put two fingers. How many grooves do you have? A groove on the top, a groove on the underside. Okay, so there's two grooves. And if you twist, even like crossing your fingers, for instance, or you twist the string of pearls, you're still only going to have two grooves, but they're going to spiral. And in that groove is the next protein, which is called tropomyosin. Okay. We have actin serving as the base, tropomyosin occupying the groove. It doesn't occupy the entire groove. It only occupies enough of the groove to accommodate 7 actin units. You don't need to remember that. Okay. But the idea is then the other side, the other groove, same thing. The other groove, same thing. Okay. Both sides are developing this. They have the tropomyosin. What for? To attach this third protein called troponin at the end. Troponin. Okay. When troponin is present and you have a regular thin filament, this is what we have here, a thin filament, and troponin is present, the ability to attach to the thick filament is not present. It's lost. The troponin is covering up the attachment site, and that makes this inoperable. But when calcium is released from the nervous system into the sarcomere, it will cause the troponin to move out of its place, open up slightly. And in that slight millisecond, the thick filament myosin can attach to the tropomyosin. They attach. They attach here. They attach everywhere. And while that thick filament is always spinning, okay, uselessly, now for a split second, or for as long as the calcium is being delivered, it can make an attachment with the thin filament and cause the spinning. Okay, and that means the thin filament is going to be drawn over the thick filament. Okay, the thick filament's not going to change. The thin filament's not changing, but they're changing positions. This is called the sliding filament theory. It's not something that you get real quick. You will get it from the scores that I see and the questions that I get asked. You'll be doing fine with this. I know right now you're thinking, oh no, now what did I get into? Okay, no, you'd be absolutely fine with this. Now, do you need to go to a book? You may want to. You may want to see it differently. I searched books for diagrams that seem to be simple enough yet accurate enough to get the idea across here. And I think you can do it just from these notes. Okay. But if you want to back it up with a book, you really should be my guest. Any questions? Okay, when we come back from our break, I'm sorry I kept you a little longer. When we come back from our break, the opportunity will be there again to ask me some more questions, and then we will just start on the lab on muscles. Okay, muscles is our next unit. We finish with the bones, except for a few questions next week. Okay. Okay. 3:35. Okay, that's. I know I'm only getting 12 minutes, but where else are you gonna go? I mean, okay. So I'll see you at 3:35. Well, I'm back. How about you?
Hi.
Howdy.
Hi.
Hi.
Okay.
Hello.
Yeah, even the thumbs up or down if you wanted to, uh, is appreciated. Some sort of interaction besides me looking at a black screen here. That's horrible. Okay, let me ask you something while I'm giving anybody else a chance to get back from the kitchen. Uh, what do you think of that last material as far as how well you're going to catch on to it? This is preliminary. That's all.
The visuals make it easier to understand.
Okay. The practice quiz that I moved from module 4 to 5, that when I showed you that earlier, that is mostly those visuals that you're talking about. Okay. I do use a lot of those on the same ones on the test itself. Okay. Okay. Anybody else got a question? Okay. Then we watch me fumble around trying to get back to shared screen. There it is. And we don't want to be there anymore. Okay, we should be sharing screen right now. And I would like to know something because I don't know the answer to it. Do the profiles that are on the side of the screen show? On the right side? I'm at the top. April's next.
Yeah, I see the profiles on the side.
Okay.
Yes.
Okay, if you ever see your profile on the shared screen and you don't want it, just turn it off like everybody else does. Okay, but I like to have somebody to talk to. So, okay, we're in week 5 here again, and we just did these myofibrils on 216. Now, today and the next lecture are devoted to digestive system. This won't be coming today, not the 216. I don't want to split it yet. Okay, so we'll do 216 on the second 216 on Thursday, and on Tuesday we'll finish the digestive system, and I'll change these dates. So uh, you don't need to go there tonight anyway. Okay. Uh, what we're going to sort of do here is take a preview of what's in the muscles section and get you ready for that. Okay. Used to teach at UCI, not my favorite place in the world. Then again, I worked at Disneyland, and that definitely is not the happiest kingdom in the world either. Maybe to the visitor, it is or was, but not to the people that work there. Uh, but I used to teach UCI, and I used to teach all different types of different classes, and one was anatomy, where I did dissection of human cadaver, and all the graduate students actually had to take part in that at different times. We all had our own classes, and I never. People would say, "Oh no, no, I can't stand it. I can't look," and things. But indeed, most of them got through it nicely. Everybody did, in fact. Now, we are going to use a cadaver in here, but of course, it's going to be through photographs of a cadaver. And they're never as pretty as you would hope that they would be. But I was always surprised how well people at UCI would adapt to it and take to it. And if you ever thought that somebody would get sick, yes, it happens. And it's always a guy. It's always a guy that gets sick. The women never get sick. And you see the door burst open. It was an inside door, inside hallway where we had teaching labs. And somebody, sort of fumbling out. Oh, and horrible mess. But that was worse than the site itself. But we would teach the cadaver and prosection in this one room. And I would work as a graduate student at night. I was almost like a vampire. I'd come out at night, and then I'd go down to the tunnels underneath Steinhaus Hall, and I made a key for myself, and I'd stay there during the day because I didn't want to be around people during the day. They interfere with your research and what you're doing. You're never going to get out of there, you know. So I was pretty much a night person. 2, 3, 4 in the morning, you'd find me up in the lab, but nobody else in the building except the janitor. The janitor, I could hear him coming when the elevator would come up. Hear that big bin he pushed around and mop he would use. And I could hear him because when he took a step, the earth moved. This was a big, big man. And wore a baseball cap, wore it backwards. You know, when you wear a baseball cap, how you IQ looks like it went down 50 points when the cap's backwards. Turn it around, you look pretty intelligent. Well, uh, this guy had only a second grade education. And I knew this because he's the only other person to talk to at 3 or 4 in the morning, and I would do it often. He came up to my laboratory door, and he goes, uh, "What's in that big shiny box in the other room that I always clean up around?" And I looked at him thinking, well, I better not tell him. And I did. I said, "It's a cadaver. It's a cadaver." And so he leaves the room and starts mopping. And then instantly he's right back in there. He says, "What's a daver?" I said, "No, no, not daver. Cadaver. It's a corpse. It's a corpse." He said, "A dead person in that room? I would know if there's a dead person in that room. I always know when there's anything like that around, and I've gone. I would have known. I would have. You're kidding me." And I said, "No, no, it's true. Come on, I'll show you." So I took him over to the room across the hall, and with the key that I had made, uh, opened up the lab and went in. Had to put his cigar out because That would be instant cremation if it hit any of the chemicals in that room. And I lifted up the lid portion of it. It swung underneath, and you swing it, and there was the cadaver. And I mean, his jaw just dropped. Called him Mr. Craig, by the way. And Mr. Craig's jaw just about hit the floor. He could not believe it. Now, the cadaver was wrapped in muslin, and I was going to close it back up. And he said, "Oh, no, let me see it." Oh, I said, "A moment ago, you were scared to death." He said, "Well, I can last a couple minutes." And so he does last a couple minutes, and I uncover, and he is just amazed. I mean, I like teaching or showing even to somebody who is amazed by the human body, thrilled to get to see it. A lot of the Bio 20 students said they weren't, but a lot of them were. Okay. Anyhow, I said, "You want to see the convertible chest?" He said, "What? What's that?" I lifted up the chest, and there's the heart and the lungs inside. And he was amazed. But then he says, "What's all this? What's all this stuff?" And I said, "Those are intestines. Those are intestines." He said, "Whoa, there's a lot of them." Uh, I said, "There's 26 feet in the average person." He said, "No way. No, can't be that much." And I said, "Sure there are. Here, you hold this end and I'll hold this end, and we'll back up and we'll see if there's 26 feet." And he refused to do it. Uh, well, he probably figured out which end I gave him to hold. Uh, so we put her back together and covered her up nicely. And he went his way that night. I went mine back to the lab, and that was that. Now, I didn't know this was going to happen, but the next day, they moved the cadaver to the physical sciences building where they had built a permanent viewing vault. They brought the gurney, the trolley, back so the vendor could pick it up and know where it was, same place it was left off. He, I mean, he, uh, the janitor, Mr. Craig, showed up about 3:30. He showed up about 3:30. I could hear him down the hall coming up the elevator again. And I decided, oh, I shouldn't have done it, but I did. I called downstairs because I knew another graduate student was there that night. And I said, "Bill," his name was Bill Gorham. He liked to be called the Lizard King, however. And I said, "Bill, come up here, please. I need your help." He said, "What do you need my help for? I'm going to home. I'm going home now." I said, "No, no, first come up here and help me. Okay. Okay, I'll be right there." And he comes down the hallway from the other direction with a gigantic peace symbol. I mean, it's 4 inches across. This was in those days. And he had long hair and everything hippie that there could be. And I said, "Come in here, Bill. Come in here to the teaching room." He said, "Well, there's nothing in here. They took the cadaver away today." I said, "I know that. I know that. That means the gurney is empty, and I don't want to go down to the basement and sleep. So hold it open for me and let me get inside." Almost no questions asked. He held it open for me. I got inside, put my head on the headboard thing, my body on the drain pad, and I said, "Well, close it up and turn off the lights and good night." And that's he left. He never asked me why I wanted to be in that. And after being in there 20 minutes, you have a lot of thoughts. And I don't know why I wanted to be in it either, except then I would remember, oh yeah, Mr. Craig is coming. Mr. Craig is coming. And I was waiting for him. And he came in the far door, swept over there forever. And then he made a mad run over to the gurney area to sweep around it. He didn't know, of course, that it was empty, and it really wasn't. I was in it. And so when he got right next to me, I put my hand underneath the lid and lifted it up and started moaning and saying, "Help me, Craig. Help me, Craig." This guy, 300 and some odd pounds of him, dropped his broom, pushed the door out, and you could hear him thumping all the way out of the building. He left. He quit 2 days later. I felt bad about that, but I found him at a better place. He was at Monteverde Elementary School. I saw him there in an open house I had to go to. He said he found a better place to work. Yeah, no cadavers. Okay. Human muscle. This is a link. Cat muscles. This is a link. I go to the human muscles. A lot of work for you. I'm sorry. I'm going to make it a little easier, however. These are the muscles over here in blue as links that we're going to learn. For each of the muscles, you're going to be asked the origin of the muscle, the insertion, and the action of the muscle. Action is the same as function. This is human musculature. And so if I pick one of these, like triceps brachii, you probably know that one. The triceps is here. Now it's labeled number 10. I can go back and see that it was number 10. The serratus anterior is here. It's number 3. You can barely see the 3 right there. There it is. And other muscles are on the same model. Whether or not they're on the same model or a separate model doesn't make any difference. These are all human. The soleus muscle is this one right here. I wouldn't expect you to know it, don't worry. Okay. Yet, but you will. Now, that was a lake. Cat muscles. People keep asking us, one, where do we get the cats? Well, we don't have any that aren't virtual this semester, but we get the cats from facilities that raise them for this purpose, that do not come from rescue or any sort of shelter. They were never anybody's pet. That doesn't make everybody feel good, but others see the necessity. For the cat muscles, it says cat musculature. All of these origins, insertions, and actions are the same as you saw on the last sheet. So you're not learning double that. Okay. These are all actually human origin, insertion, and action, which you're going to need to be able to identify muscles on the cat. I've looked at the cat many times, and to counter the argument, well, why do cat muscles? We're doing human anatomy. Well, we are doing human anatomy, but we don't have 100 cadavers to work with. And on the cat, there's only about six muscles that are so different that we really have to point them out. Okay, so most of them are the same, but when you're on the cat muscle page, I'll look at the serratus anterior because we looked at it a moment ago. Now, this is a small picture which I could enlarge, but you'll see. Here's the serratus anterior. All I have to do is double click it, and you get a full screen. This is the serratus anterior. We did the soleus. That's number 46 or so. Okay, number 46, but you got to see it bigger. Here it is. This is the calf muscle, the gastrocnemius, the soleus. On the lateral side, this is the fibularis longus. This little one right in here, extensor digitorum. And the one in the front without a pin here is the tibialis anterior. You'll be able to rattle these off. I know you don't think so, but I'm not the least concerned. My greatest concern is that somebody will give up before they even make an attempt, because this is not that bad. People always ask me, how do people do on the test, the practicum, compared to the bones? Usually about the same. Usually about the same. Okay. Now I'm going to go to the human muscle page again. Okay, so this is an external link. This links to my website. Okay. And that website still says 2020 instead of 2021. That's not important, but it can be used. I'll show you where in just a moment. If you look at the URL up here, C. Harrison, my name, SM muscles, that stands for small muscles. That's just what I named it at the time. But then there's a period or dot HTML, hypertext markup. I'll post this for you. I never have posted it for anybody before, but I will for you guys. And I'm going to change this last word to hidden in case somebody wants to get there before I actually do the change. And then hit. What happened? It just says musculature now. Okay. What happened is the name of the muscle is the same. It goes to human muscles. The origin and insertion are not the same. Instead of a long drawn out origin and insertion, you have a more abbreviated version. Still correct. The actions are the same. So when I first hit you with those, that full page, realize that this is not as difficult as that full page may have looked. You're welcome to learn all of the origins and insertions, but this is what the part that you're required to. Origin, insertions, and the action. And as I said, I'll post the link to this. I gave you the link to my website, which was Bio11. I'll see, I haven't changed that because I haven't felt the need to, but I will. All these links would be the same for you. And you can come over to the human muscles, cat muscles, okay, pictures of the skeletal, cardiac, and smooth muscle, which we've seen already. You come to here, you see the same thing. Okay. Actually, it looks a little bit bigger. And you would have to go to hidden, and you'd end up at the same place. Okay, so let's look at the only other three remaining things. Look at one of them. Muscles of the uh, back to hand out. Okay. Now you have your lecture exam to study for, most important. But you're like, you don't spend all the time studying. And you got to have something else to do. So I would pick maybe this first set here of from the handout of the back. Okay. Here's the trapezius muscle. This muscle is a roughly triangular muscle. Here it's shown here, then it curves in here. This pulls the head back. It pulls the shoulders back. It helps you arch your back backwards. Trapezius muscle. It's also one of those muscles that really gives people uh, backache, essentially, when things go wrong, when your back goes out. If you want to make cards out of it, they're already printed in. Here's the origin, insertion, action. Okay. We've got the name already on the card. So you could print this page if you wanted to. The latissimus dorsi, or here, latissimus dorsi, its primary function is to pull the humerus backward. In other words, to pull the arm backward. Here's the trapezius again, latissimus dorsi. That's a great hint right there. I know you don't know, we haven't talked about the word synergist, two muscles that work the same. The supraspinatus occupies the supraspinatus fossa, number 1. 2 is the trapezius. It's a portion of the trapezius called the clavotrapezius. We also have the spinotrapezius, the part that you saw going down. This one shows the supraspinatus at the top here, and here's the infraspinatus here, which is deep to the trapezius, which has been left off of this. Okay, occupies the infraspinatus fossa. "51 questions out of 100 questions on the muscle practicum." That's practicum number 2. 51 questions are for you to name something. Name this muscle. Name this muscle. And some things, we have connective tissues in here, but it's name it. The other 49 questions are those origins, insertions, and actions. And the one that's asked most frequently is the action, what it does. And then the origin, a few of those, and very few insertions. That'll be on the recording for those who didn't get to write it down. The subscapularis, that's not going to give you any trouble. That occupies the subscapularis fossa. The rhomboides, you put your shoulder blades together behind you as close as you can. That's going to be pulled by the rhomboides here, here. There's 2 colors because one's the rhomboides major and minor. You're just being held for the rhomboides. Here's the origin, insertion, action. This is the back of the shoulder blade, scapula. Okay. The supraspinatus is up here, almost off the grid. The infraspinatus is here. This guy down here, this is the teres major. This is the teres minor. The teres major and minor, it sounds like they should be doing the same thing. No, they don't. The teres major down here, okay, the back of the scapula, actually helps to pull the humerus, just like the latissimus dorsi does. The teres minor is a rotator cuff muscle, helps move the head of the humerus in the glenoid fossa. So Terry's major, Terry's minor, infraspinatus, this is also infraspinatus, this is also infraspinatus. This one shows the Terry's minor. Okay. And its origin, lateral border of the scapula. Have to think for a second, don't you? Lateral border of the scapula. Oh yeah, that was over here underneath the armpit. Okay. Insertion to the greater tubercle of the humerus. In action, it's a synergist to the infraspinatus. So the card's not telling you what the action is. The card is saying, go and look at the infraspinatus to find out what the action is. The erector spinae, I've heard it pronounced erector spinae as well. Long muscle, you never see it drawn, okay? A little bit of it showing right here. And this is the muscle that flexes the back. This is the one where if you bent over to pick up a coin, now you're straightening yourself out, or you're trying to keep yourself straight in the chair. This is the one that's going to do that. Okay. Now, that was just sort of to give you a taste of the muscles. Uh, it is more exciting if you have a specimen in front of you. But we'll be going through these with a quiz almost every day for practice, and you'll be able to latch onto those nicely. But the first thing is that we have the lecture test. Okay, so I would feel more comfortable if I got more questions, because that means you're having a little bit of trouble, but you're trying, you know. Uh, maybe some people don't have any trouble. Well, I'm a worrier. I'm a worrier. So if you have any questions, you can either email me or you can bring them up with you on Thursday and next Tuesday. And okay, any questions now?
I have a question. The practice exam the practice quiz number 4, is that going to be due on Monday of next week as well, or is that already due? I was already due on this previous Monday.
Uh, that practice quiz number 4, you are ready to take it now. By that I mean it includes only lecture material that I did today or earlier. Okay, so and for me to even want to answer when a practice quiz is due, when I throw out a practice quiz, it's to help you, and I can't believe it sometimes when they come in at midnight or something. It's like, don't you want the help? Don't you want the clues? Don't you want the hints? Uh, just get it in before the test. I don't really
Okay.
care. I don't really care about Monday or Friday. You know, if somebody doesn't want to use it, that's their problem. And but I'd like to help you get the highest grade you can. Okay.
Will there be any imaging or labeling type questions on the exam for the lecture?
Yes, there will not be many, uh, but let's see. I often use matching. Now, how do you do matching on a test like this? You draw the picture, put a number by it, the question number, and then you give a series of answers with letters by them, and it's quite easy to do matching. I'm trying to think right now, though, what I've done on that first test. I've already, well, I'm not finished with it. I mean, I have to remake each test, but I use a lot of the same types of questions. There will be matching. There will be images. There's nothing that you shouldn't know. There's nothing you shouldn't know. Let me look over the test between now and Thursday. And if you would please ask me the question again, I can give you a better answer.
Okay, thanks.
Okay, then. No questions any further. Your job right now is get busy on chapter 23 so you don't scrunch up against the the exam. Study for the examination, all that lecture material that we had done previously. Uh, Look for your email from me that has the information that's what's going to be on the exam itself. If you don't find that from somebody else or from me, it's fine. Ask for it again. And just, I would suggest taking a quick look over the muscles of the back or any of the other ones that you want to get a little head start on. A lot of people will take the printout, the links, and look up just those muscles to start. They know, in other words, they know the calf muscle, the gastrocnemius, or they know the chest muscle, the pectoralis major. They'll look those up and get those marked off. Okay, lots of things, lots of things you can do. So
Professor,
yes,
I just have a quick question. I'm not quite sure if anyone asked this question before, but would it be possible to give us extra time on the exam
no,
just because of a technical issue that might happen? Like for example, my picture took a while to load, and I don't know if anyone faced that issue, but just like a bit of extra time in case something happened. Because
no.
at the end I didn't really have time to like view all the photos that you uploaded.
If there's a problem with somebody, as there was this time too, there was a problem. I solved it when they contacted me. Uh, and if there's a slowdown of some sort, I will adjust it for everybody. I'm sitting here watching the test. I know how many questions each student has answered, how far along they are. I get sometimes if somebody say, I need more time and they've already finished the test. That's not right. But that's rare. But this last time, a person was having trouble. It wouldn't load. It wouldn't load. And so we finally ended up having to submit the test with only a few answers and start a brand new test. And then it worked perfectly. And I adjusted the time as needed. So I have not heard from anybody that they needed more time. If you would like me to look over your log, I can look at your log and I can see how many minutes, for instance, it took you for every question. But I'm not going to change it ahead of the test. That just doesn't. That's just something I won't do. I will be fair, and if you need more time because of a serious thing, like for instance, poor internet. I had one person before. Really couldn't help her because there was always poor internet. So I can make the adjustment because like I said, I'm sitting here. I can look and see what your problem is. Okay, and I will. And I've had to do it on some adjustment on every single test that Canvas has put out. You know, I shouldn't blame Canvas. I can blame the internet itself. And one person was using a cell phone that doesn't fly. Okay. Okay, you're of course welcome to exit at any point here. I usually wait around to see who has the last one, last question.
Thank you, Charlie.
Bye-bye.
Thank you. Have a good night.
Thank you.